This video is brought to you by Cooper City Realty. We are Cooper City. So this is a really easy one. It wants us to find the moment of inertia of the cross-section of this beam about the x-axis. Now, whatever you're rotating about is important, whether it's the x-axis, whether it's the y-axis, because that's going to come into play when we're looking for our d in this equation. Basically, to find these types of problems, to find the answer to these types of problems, we're going to be using this equation, I plus a times d squared. So I could change based on the shape, whether it's a triangle, whether it's a square, whatever it is. In this case, it's all rectangles. So the I portion for the rectangles is going to be bh to the third over 12. Now in the back of your statics textbooks, there's a list with the different shapes of the different centroids and the different moment of inertia equations for that as well. So you always take a look at that. And sometimes on your final, on your exam, your teacher will actually give this to you, so you don't have to memorize it. But this is an important one to know because you use this a lot because we deal a lot mostly with rectangles and some triangles too, but for this one it's all rectangles. So what I did was I split it up into 3 different sections. This is section 1, this right here is section 2, and this right here is section 3. So we're going to do this equation for each and every section, and then at the end we're going to add them all up together. So let's get started with section 1 here. The base of section 1 is 200. The height is going to be 30, so make sure you put that to the third. And all that is divided by 12. Base times height for our area here is going to be 6,000. Now the D is tricky. The D is the distance between the centroid of our section and whatever we're rotating it about. So for instance, we're dealing with section 1 here. So we're rotating about the x-axis, right? So the centroid going this way, if this is 30, would just be in the middle because it's a rectangle. So it's 15. So the distance between the centroid of our section, which is 15, and our x-axis is just 15, this portion right here. So our D for section 1 is just going to be 15, and make sure to square that. So when you compile all these numbers, you get 1,800,000 millimeters to the fourth, because we're dealing in millimeters, and for moment of inertia, the units is always with whatever you're dealing with to the fourth. So let's clean this up, put it up here, and move on to section 2. Alright, so there's our answer for section 1. Now let's move on to section 2, basically the exact same way. Now remember, this is base times height, but depending on what you're rotating about, the base and the height could flip. For instance, this way, the x-axis, the base is down here and the height's down here. More intuitive. However, if it asks you to rotate about the y-axis, it's flipped. So the base would now be here, and the height is here. One more time, since we're rotating about the x-axis, the base is here, and the height is here. But if the problem were to ask you about the y-axis, then the base would be here, and the height would be here. So let's look at section 2 here. And the base, right here, is base and height, because we're rotating about the x-axis. The base is going to be 30. And the height is going to be 140 to the third. And all that's over 12. Now our area here, base times height, is going to be 4,200 for the area for just section 2. And our D is going to be the centroid of this section. So if this is 140, the centroid of just that section would be 70. So it's the distance between the centroid and what we're rotating about. So since this centroid is 70, we also have to add this 30 here because we're rotating about the x-axis. So 140, so we get 70 and 30. So all in all, 70 plus 30 is 100. So our D for section 2 is 100. Make sure to square that. And when you compile all these numbers together, you're going to get 4,886,000. So let's clean this up a little bit and work on section 3. So next and final section is section 3. So again, we're just going to use this equation. The base of section 3 is going to be 100. The height is going to be 30. That's to the third. Put all this over 12. Plus the area of section 3 is going to be 3,000. And finally our D. So the centroid going this way is half of this. So this is 30, so it would be 15. So this part would be 15. But it's the distance between the centroid of our section and we're rotating about. So it would be 15 plus 140 plus 30. So that's 185. Make sure to square that. And when you compile all these numbers together, it's going to come out to 102,900,000. So that's our answer for 3. So All in all we have to do is add 1, add 2, and add 3 all together, and that'll give you a final answer of 1.54 times 10 to the 8th. Don't forget your units, millimeters to the 4th. And there you go. That is the moment of inertia for the cross-section of this beam about the x-axis.